Good evening, everyone. Welcome to the live chat. It is the Thanksgiving live chat, the night before Thanksgiving. We're all prepping. You might hear Susan in the background getting the turkey ready. Everything is unfolding. We have the Christmas tree up. We have to put the lights on later. And the weather is actually pretty good for travel. So before we begin, I do have to say one very important thank you to all of you who have been subscribing, premium members, everyone that's on YouTube, of course, the live chat here, and of course, we're also running right now on Discord. If you're watching on there, hello. It's the first time we're trying this out, so definitely check that out. Hopefully that's working out really nicely. Of course, we have everyone asking questions already. Questions are already flying in here. So I was thinking, where do I want to start tonight in terms of this chat? Because there's a lot of stuff to touch on here. We could talk about the high latitude blocking. Talking about the snow season getting ready to go. Again, we're going to talk about that because I want to make some things clear here. I want to show you a couple of tricks I use when it comes to long-term forecasting in terms of trying to understand what type of pattern we're dealing with. So I'm going to go over that. And there's a couple other things. Of course, I'm going to take your questions. Take a look at the forecast for the upcoming weekend. And, of course, drink my coffee. Got my little Batman mug here. There we go. See? Some people call me the Batman of meteorology, which I find to be hilarious. And at the same time, true. So, let's get at it, right? So, let's go see what we got here in terms of data. Where should we start first? I guess we should start at the pattern overall, and might as well answer these questions. What's going on now? You know, I've been talking about high latitude blocking and about the disruption of the polar vortex and all that stuff, but I want to show you an observation that really has my attention. I brought this up with the premium members a couple of days ago and went on a video about it and discussion. And again, fire in your questions because then I'll answer them after I'm done with my little rant here of what I wanted to talk about, and then I'll answer everyone's questions. And again, wow, look at the activity already in YouTube, absolutely outstanding. Happy Thanksgiving, everyone, and also on all right, on Discord too, pretty active, very good. Okay, so where do we want to start? So, as I was saying, we can clearly see we have a nice disruption here in the polar vortex here. And you can see over the next 10 days, we have stretching going on. This is not a consolidated polar vortex, but one that is getting beaten around like Mike Tyson beating up a heavy bag. It is just getting warped and messed up here. And a key signal, as we've been talking about, is this feature right here, building heights in the atmosphere, causing that disruption. But you know what really catches my eye? What really makes me say, something unusual is about to evolve here. And it's not so much the high latitude blocking, it's not so much the disruption of the polar vortex, which is pretty impressive, something that we haven't seen in about a decade. It is, and I hope I click on the right one, probably won't, this feature right here in this forecast. Look at what's been happening here with the MJO. It has been stuck in phases 6, 7, and 8 for quite some time. And if anything, it has migrated from a 5, 6, 7 feature in the fall to now a phase 6, 7, and 8 as we head towards winter. What does that mean in real time, in observations, you might be asking? Because everyone looks at things in statistics and model guidance, but sometimes you got to step away from all that and take a look at a satellite picture. Voila. This is the infrared satellite picture for all of the Pacific, and you can also see the Atlantic here. Take a look at the way that the convection is developing here. We have a lot of convection here, here, and here. When we study Coaston and Usoni's books on northeast snowstorms, one thing that starts to show up frequently is the potential for convection to develop around the dateline. Now, typically in a La Nina year, this whole feature gets shut down completely. Okay, you might spark up a few thunderstorms, but because of the cold water, you really don't see much in the way of convection. You really see this type of feature show up in El Nino years, because you have warm water, above normal water, sea surface temperatures, a stronger gradient, everything's off the hook, right? But not this year. This year, with a strong east-based La Nina, which you can see the influences here, you're getting that convection popping up right around the dateline. Now, why is this important? Okay, when you look at the atmosphere, don't just look at it as 2D chest. Maybe not even 4D chest. How about 8D chest? Okay? Because what you want to do is look at how each factor is impacting the atmosphere from a vertical, horizontal phases, but also how those different phases interact on each other, right? So you kind of have to think about this. Close your eyes and think about. You have the convection building up. It's growing and enhancing the subtropical jet stream, but you're also having a latent heat release, right? So that latent heat release is impacting the mass dynamics in the atmosphere and altering the rising and sinking motion in the horizontal and the vertical planes at the same time, within a dynamic in which we have a known instability in the atmosphere and the stratosphere from a volcano, right? So you combine all that, and then you start to see what's happening, and you can literally see the embodiment of the winter forecast that I put out back in October right here. Now you might be saying, Stephen, what does that mean? It flew right over my head. Okay. What that means is that the convection development here enhances our subtropical jet stream, which has definitely been far more active. But it also enhances the latent heat release to enhance the potential for these short waves here marching across the Pacific. And we're seeing stronger and stronger support for a negative EPO pattern as a result. Now, that negative EPO pattern leads to more amplification of the polar jet stream. The amplification of the polar jet stream, combined with what is happening with the polar vortex, increases your potential for high latitude blocking. But the signal that tells us that things are evolving the way they are, and that the long-range models that are showing up with this negative EPO, AO, and NAO pattern are onto the right direction. What I mean by that is that this is your physical signal to support this. And this, and this, and this. You get my point? The models are only picking up now what is happening in the atmosphere and the warping that's happening in the atmosphere. And so now, as a result, you're starting to gain more and more support for the high latitude blocking that has been forecasted back in October by me, showing up now in the operational and also the ensemble guidance. But what does this actually look like? Well, a lot of people, what they like to do, and let me see if I can pull up the right guidance here. I got too many models to come up here. Okay, here we are. Okay, so a lot of people, what they like to do is look at the 500 millibar heights, and then they make their declarations about the pattern. This is above normal, below normal, there's a ridge here, so this means a lot of people look at this and say, oh, this is a ridge, but it's not a ridge. You could see this here. What you have here is a lot of confluence here. Right? So what is actually evolving here? What I like to do is I like to look at the winds and see what's actually developing there. And this is a little tool that I use that I don't see a lot in social media land. I see a lot of the 500 millibar heights because it's nice and flashy and people could go ooh and ah and look at it, right? But they don't really tell the whole story. When I'm looking at the 300 millibar winds, i.e. the jet stream, it gives me a better idea of what type of pattern we're actually dealing with. So we'll go out to 15 days out, and again, you never take this verbatim, but what are we actually seeing here? Well, we're seeing here hints of a convergence of the subtropical and polar jet stream over the Ohio River Valley. We're seeing support for high latitude blocking with winds backing over Greenland. And we're seeing what signs of possibly a negative tilt in the broader polar jet stream here. Potential that we could see the polar vortex drop south towards the Hudson Bay. This pattern here is not a massive Arctic outbreak type pattern where the Arctic air mass going into Texas and into the southeast. This pattern heading into early December is a cold press. What I mean by that is that most likely what you're going to have are cold fronts and clippers marching their way from the plains of Canada through the Great Lakes and towards the mid-Atlantic, with cold air pressing down with each wave. And with each wave, you're going to get fast-moving low-pressure systems, possibly blowing up a bit off the mid-Atlantic coast, potentially producing a surprise snowfall here over the northern mid-Atlantic. Given this time period, early December, most likely with ocean influences, you'd probably look at a scenario of wintry mix or rain on the coast and snow over the interior. However, what this gets to us in early December is this pressing down and evolution of the pattern such that each wave leads to a colder and colder solution. So then let's go to the next forecast, which is our longer term EPS forecast. Again, here's our 500 millibar heights, and here's our hints showing up for December into January. Notice our polar vortex. Look at the lower heights here, focusing closer towards the Hudson Bay. Now, when you're out this far out, your signals become more muted, right? But you can see some of the hints here. Let's see what this looks like with winds. Let's see if we have our upper level winds showing up tonight. Of course not. That's okay. So what this scenario shows us here, when we look at this pattern, is one in which December is going to be your month where you get cold air pressing south. I think mid to late December, based on what we're seeing here, is going to be your time period for best potential for sustained cold air. But because of the nature of this pattern, I think it comes in waves. Right? I think that your traditional nor'easters that you look for, were like a storm blowing up the coast and slowly marching up the coast, I think that's more January and February. Historically, it's usually more January and February. Sometimes you pull it off the last week of December, like the Boxer Day blizzard. Not that I'm saying that's going to happen, but I'm saying in terms of the pattern evolution, if I was looking for something like that, I would say from December 25th to February 15th would be your better potential for that, because by then you lock in your high latitude blocking and your pattern starts to mature. Right now, I would say December is going to be that time period where we transition to our late fall to our winter pattern, and we start to see the full amplification and how that's going to feed back and feed into this pattern. And with that, I want to be careful when I say this, because I know it's going to go a little nuts here. I would say this December, statistically, based on the observations, has one of the best potentials to see snow on the ground around the end of the year, Christmas time period. Somewhere between a 30 to 45% chance, which is pretty high for this time of year. Now, what's special about this pattern that we're going into is that, unlike other years where we had to wait for high latitude blocking to disrupt the polar vortex, where we had to wait for tropical forcing to shift and support the upcoming pattern, that's all there. We don't have to wait. It's here. It's just a matter of it maturing. In other words, the cake is in the oven. We're just waiting for it to get done. It's there. So tonight, I will answer a lot of your questions. I already see them coming in. I will definitely answer all of them. But this is going to be pretty interesting, I think, in the way that this pattern is going to evolve. And with the way that this pattern is evolving, and I think this week was a great example of this, because of the evolution of the subtropical and polar jet stream, because of this type of signal here, use extreme caution when looking at storms 7 and 10 days out. The forecast of phasing of these short waves is going to be total garbage. Whether you're looking at the European, the GFS, UK Med, Jamaican model, I don't care what you... With this storm alone, people were pulling out models from like Taiwan and stuff. Look, models historically do a really, really rough job when it comes to phasing, because you're dealing with ultimate chaos. That's what I like to call it. How about that? Dragon Ball could use that. Ultimate chaos, right? You have Ultra Instinct. How about ultimate chaos? This is ultimate chaos, right? In terms of how these short waves are going to be interacting. So I would say you don't get your true forecast until you get under 120 hours. Even in this case, we really didn't see everything play out until we got to under 90 hours. And how the short waves interact will basically be to tell the story for each storm. And each storm is going to be different. There's not going to be one theme or one theme for the winter. You're gonna have to be on your toes with this winter, because if you get stuck trying to forecast the last storm with the current one, i.e., a lot of people, they say, well, the last storm did this, so this storm will do that, and they don't forecast for the actual observations, but what happened previously, because they got burnt. What you want to do is learn from that example, but understand also you're dealing with a new dynamic, a new environment. This is going to be a winter that's going to test forecasters. It's going to test me big time. I sense a lot of challenges and a lot of coffee being drank, because I think that this is going to be the type of winter where you better have your skills ready with your water vapor satellite picture analysis. I think that's what we're dealing with here heading in. Now, heading into the Thanksgiving weekend, well, let's take a look at our water vapor satellite picture. Well, we're already seeing the separation between the polar jet stream and our shortwave cutting off into the subtropical jet stream. Nice upper level lows starting to form here. Moisture's being drawn northward. Could be some severe weather out here in Texas as a result. Here comes our cold front getting ready to set up for Friday. This is going to be a fast-moving system on Friday. And based on what I'm seeing here with the latest model guidance, using the NAM model guidance, for example, fast-moving cold front moving through, looks like impacts from about, I'd say 6 a.m. to about noon on Black Friday. So if you're one of those people that happens to be going out shopping for some reason, personally, just going to Amazon it, whatever, you're going to be dealing with rain in the morning. The afternoon, you'll be drying out. But even on the latest European guidance, it's showing basically the same thing. Thanksgiving is quiet. Today's been quiet. Tomorrow's going to be quiet. And our cold front's moving through in the morning hours. So it moves through pretty quickly. So this isn't going to be a washout or anything on Friday. Then for Sunday, because I know everyone's been asking about that, especially with the Jets game. I might actually watch the Jets game now. I think it comes on before the Chiefs game with the quarterback.
Show first.
Oh, yeah, the National. Well, that's on Thanksgiving, hon. We'll watch that on Thanksgiving. We'll watch the dog show on Thanksgiving, then the Giants game at 4 o'clock, and then we'll do the Jets game on Sunday, followed by the Chiefs game. Sounds fair?
Whatever.
Yeah.
Dog show.
Dog show. Okay, we're definitely watching the dog show. As far as Sunday, this looks like more like a late afternoon, evening threat. And the reason why this is not looking as impressive as it was a couple of days ago is because your strongest lifting is now focused over the Eastern Great Lakes. Take a look at this. If I can pull up the right suite. Here we go. Okay, so there's our first cold front. There's our storm coming through. Beforehand, you had your upper level low marching through New Jersey. Now all the guidance is lifting it through the Eastern Great Lakes. So this is more of just a normal cold front passage scenario with rain in the afternoon and evening. Still maybe about a half an inch to an inch and a half of rain out of this, but it's not an all-day event. And then here comes our next storm. Now notice the storm track here is all to the north and west of us, but each storm track starts to introduce colder and colder air as it steps through. So again, we're in a step-down pattern, not in a flip, and you're going to see a more aggressive step-down pattern as we move through December. So I think that's... Let's see, is there anything else I want to cover here? Oh, yeah. Our SOI is falling. Oh, did that one. Oh, right. Snowfall coverage. I wanted to show you this. And let's see if it got updated yet. Here we are. The reason why I want to show you this is that Siberia throughout this month has become very cold and snowy. Why is that important? Well, some recent research into the evolution of what's going on in Siberia and how that pertains to the polar vortex have found that, yes, snow growth is very important in October. That's still very valid. But also, the colder it gets in November in Siberia, the more likely you start ending up with stronger and stronger disruption from that process of the polar vortex. And this year has featured some pretty chilly temperatures around Siberia, in some cases near record cold temperatures, which is an indication of another feature that's going to cause further disruption of the polar vortex as we head into January and February. So I just wanted to show you that. Some pretty interesting stuff. More often than not, we have above normal snowfall throughout the northern hemisphere. So a lot of interesting stuff there. Now it's time to take a look and see all your questions. We're going to answer everything in the premium chat first. I will pick the best questions on YouTube and also on Discord. And we will go from there. So let's see here. Let's go back to the community chat. Check that out. And okay, of course, happy Thanksgiving, everyone. All right. So let's see here. Have never seen the 10 millibar PV with not one but two strong feeds from the equator tropics all the way to the PV. One from near Indonesia, and the other one from Africa. Okay, so let's take a look at 10 millibars, shall we? So what we're seeing here is dual disruption. Very interesting, right? You're seeing two feeds of generally tropical air pushing into the higher latitudes, helping to disrupt this polar vortex. And we got a near split here, not completely. It's severely stretched. It's not a full split until you start to see these winds get cut off here. But it's pretty close. Pretty impressive stuff at 10 millibars. Again, in years past, we had to wait until we see any type of disruption from a polar vortex. Usually we have a very strong polar vortex right now. This is as weak as you can get. All right, let's see. Waiting for the snow season to begin. Indeed. I would say the same thing about 70 millibars, but at 70 millibars, it looks like a northern hemisphere vortex rather than a polar vortex. Well, let's see here. If anything, 70 millibars is a little bit more. It's as close as you could possibly get to getting to being a split without being a split. It's still severely elongated. Pretty impressive. Hi, Denny. Happy Thanksgiving. Are you seeing any similarities between this December and December 2019? Keep hearing that is that kind of potential. I don't think tropically it's the same forcing mechanisms. And while I could see the potential in terms of the high latitude blocking regime, I think that the processes to get there are different than what this is. So to me, physical forcing properties are very important. And if there's a difference between the two, I don't like using similarities. Again, the year that I am, and I know I'm going to get in trouble for this, the years that I'm focusing on in terms of similar forcing mechanisms comes down to 1 year. And I'm going to get beat up for this, and that is 95-96. That is the year that really stands out to me in terms of forcing mechanisms. Not that I'm expecting the same output. I'm not. Because that would be ridiculous to expect that. Because, again, 95-96 was literally just a perfect high latitude blocking regime scenario that's set up. But I think that the forcing mechanisms are a little bit different than compared to what we saw in 2009. How you doing, hon? You're hot? Okay. She's doing a great job with the turkey and stuff.
He's in the fridge. Big Bird has landed in the fridge.
Big Bird's in the fridge. There you go. I think the phrase beaten like a government mule applies to the polar vortex. Probably, yeah. In other words, the models reflect the actual observations and how things have actually developed. Exactly. The long-range models, again, I would not focus on details, but the overall theme looks to be well supported by the observations. We have a couple of winters where we got a series of clippers that dropped decent snow with a couple mixed in that got stalled off the coast and really blew up. Yes. I am hesitant to go with the blow up off the coast idea until I get a better idea of the position of the 50-50 low within 48 hours of these events, because that could be a real tricky feature to forecast for. But I would say, again, this December is probably one of the best Decembers we've seen in terms of potential in over a decade. I'm just going to say that. There's a lot of potential. Are we talking sustained cold or is it more transitory? I think for December it's more transient. But I would say that there's a greater support if we reach the high latitude blocking regimes I think we're going to reach, and we reach the disruption I think we're going to reach with the polar vortex. I think you have a better potential for sustained cold in January through mid-February than you do in December. December, I really see it as that transient evolution time period, right? So you'll get an arc blast, and then you'll get a retreat, and then an arc blast again. I can see that evolving. December 13 was like that. Storms were forecasted weak, then ended up with double the forecast amounts in the Lehigh Valley, PA. You know what I think led to a lot of that in 2013 was the difficulty in forecasting the mesoscale banding in those storms. We had a lot of enhancement in mesoscale banding that led to a lot of impressive storms. And I think part of that was that we were dealing with better model data that we weren't sure whether we were dealing with convective feedback or not. And so there were a lot of adjustments made in the physics involved in those models in 2013, which led to a lot of wacky forecasts. I think also we started to see more of an influence from enhanced precipitable water values in the atmosphere. I think started to really play a role as well. What is this timing for Sunday rain, wind? Do you expect any coastal flooding? No, I don't expect any coastal flooding at all. What I do expect on Sunday is probably the most of your rain to be from the probably 2 p.m. to 9 p.m. hours. Steve, so stocking up on lots of coffee? You bet.
Always.
We got like a ton of coffee in there now, and still buying more.
Yeah. It's always going.
That's true. Where do you see the best potential for snowfall for the first half of December? Do any of them have the potential to be big? I don't see any. Okay, let me be careful here. In terms of the Northeast, your best potential for big snowfall would probably be the Great Lakes, mostly driven by lake effect snow. Not that we haven't seen it already, and that's because of the clipper nature with driving these cold air masses in, and the Great Lakes still warm. For the northern Mid-Atlantic, I can't forecast big snowfall because climatologically speaking, it's really not supported. And I don't have the strongest data to make that statement. What I would say is that if you're looking for sustained accumulated snowfall, I would feel more confident of that in the Poconos, Catskills, Hudson Highlands, Hudson River Valley, more so than anything in the coastal plain. How about them Cowboys or Giants? Hey, whoever you root for, whatever happens, I just hope it's a good game and that the Chiefs win. But they're not playing, so they're not playing until later Sunday.
Everybody eats well.
And everyone eats well. Lehigh Valley, PA, December 95, we had 19.3 inches. 2009 was 15.4 and 13. Yeah. Normal December 4.6. I know your biggest analog season was 95-96, so it's game on. Yeah, again, I feel like I'm going to kick myself for even mentioning 95-96 because people are going to be looking for like those 73 inches of snow and stuff like that. And I want to be clear, I don't think we're going to reach that type of level. At least I don't have the data to support it. To make that statement, because that's an insane statement. That's like a record. That's like saying you're going to break a record in snowfall, right? But I'm looking at the physics, and we went with this with the winter forecast. I'm looking at the lifting parameters and everything that's evolving here, and I'm looking at the fact we have the weakest polar vortex and the sea surface temperatures. By the way, let me pull that up. I mean, this is a carbon copy of 95-96. Literally, it's so close, it's not even funny. You have your warm water here in the northern Pacific, clear, it's beginning to weaken east base La Nina. You have convection around the date line. You have a warm northern Atlantic supporting a feedback process for a negative NAO pattern. I mean, wow. I thought I saw a ghost when I saw this at first in the fall. I'm like, it can't be. But the reason why I'm focusing on that is, again, when I looked at this setup in the sea surface temperature anomalies, and I looked at the QBO factors, and I looked at the polar vortex, and I combined all those together, there is only 1 year that meets all that criteria. So you have to use it. I'm not saying it's going to be word for word the same season, but in terms of forcing parameters, this is as close as a match as we've seen in years. Those lake cutters laid down snow to our north and west, which helps keep cold air out later on. That is true. That's definitely true. And that's why this observation is so important to me. Let me see if I can do the actual snow chart here. The more we build up snow here, which again is near to above normal, The reason why that's important is because this builds up all your Arctic air. Now remember in years past where we start building up snow in October and then this month in November, this gets wiped out and it's all barren, right? How many times have we seen that? And when that happens, then these Arctic air masses try to come down and then they moderate really fast. This year, the snowpack is building and it is rocking in Canada. And that is basically, ladies and gentlemen, our freezer. The freezer is fully stocked and loading up with plenty of cold air. And now that cold air is getting ready to drop south. And now we're moving into December. That's going to be a big deal. This why it's so important to keep an eye on your cryosphere to see how things are evolving. Because if your freezer is already full of ice, when that cold air comes out, it's going to be frigid. Steve, if you had to choose what's the one main difference between this winter and recent winters we've had? Okay, the one main difference is that we already have a weak polar vortex. Every other year, going back to 2000, heck, I probably have to go all the way back to 2009. Every other fall, we've entered the fall with a strong polar vortex, and then we look at the processes that would weaken it. And then we said, well, maybe late December, January, and February, we could see some high latitude blocking. This year, there is no waiting. It's here. The polar vortex is weak. The potential for it to strengthen has been shot. Because remember, for November, the story was, okay, it was weak all through October, and then we should see a strengthening polar vortex. We did start to see a strengthening polar vortex, and then it got uppercut by more disruption from our EP flux, and the EP flux basically came in like Mike Tyson and knocked it out, right? And so as a result, you ended up with this severe disruption, and now we're already starting to see the high latitude blocking. So the point is that we're not waiting. It's here. Now it's just a matter of, as the pattern is evolving, remember we're going to be changing the wavelengths even more, because we're going to see even more of a stronger thermal gradient as we move into December. So as a result, we're going to see even more amplification of the polar and subtropical jet streams. And now the only question is, how do these short waves interact, and how is that going to lead to big storms? I should warn you, not every storm is going to lead to a major winter storm here. That's not how winter works. We're going to have some storms that are going to cut up towards the Great Lakes, and we're all just going to be rain here. Okay? It's really, 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 really rare, which is why 95-96 is a real weird year, where you have storm after storm after storm cutting through Delaware or cutting through Virginia and supporting snowfall here. And even in 95-96, we had a thaw, so to speak. So the only year where I can think of where we didn't have a warm-up in the winter would be when we had that supervolcano go off around Indonesia. And we had the year without summer. So that's it. Unless you're expecting a supervolcano to go off, you're going to have a thaw at some point, right? But this is a pattern where you can end up with 2 or 3 winter storms in a row, really producing a lot. Then we warm up, and then another string of winter storms. And one that's going to keep us on our toes. And let's be honest here. Usually around here, our winters are made after 1 or 2 major winter storms, right? We get 1 to 2 feet of snow. Most on the coastal plain, we're like, oh, we're happy. So if you get 3 or more, you start like saying, wow, this is an impressive winter. 95-96 had like 15. See my point? 2009-2010 had really 6 major storms and a couple of minor little mini ones. So you kind of see my point here. It could be interesting. Even 95-96 had some transient periods. Yes, it did. 1 week after the huge 3-foot snow blizzard, we had 60 degrees, exactly, and several inches of rain, which led to massive flooding. Exactly. That's how the atmosphere works. With the rain coming in upstate New York and 80 inches of snow, they just got Will there be flood potential up there? Maybe even root collapses. Unfortunately, I would not be surprised by that. Although I'm sure up there that they're kind of prepared for it in a way. But still, it's not going to be pretty. Right, Mount Tabarora. Right, I'm horrible. I am, I am so good at butchering the English language. I literally made my English teacher retire. That's how bad I am. He was convinced I was just trying to make up my own language.
Yeah, I correct you on things.
Yeah, I'm pretty bad. What can I say? Let's check out YouTube. Wow, it is busy. Hello. Happy Thanksgiving, everyone on YouTube. Good evening, Steve. I'm Huss, wondering about the potential storm for the second half of the holiday weekend. Overall, this storm right now is not looking as impressive as it was a couple of days ago. I think Sunday's still going to be one where in the afternoon and evening you're going to be dealing with some heavier rainfall, but it's not a washout. I'll put it that way. Good evening, Mother Russia. I get it, Russia. Yeah. Happy Thanksgiving, Kenneth. Let's see. Good evening, Jose Garcia. Dylan asks, good evening, Steven. Love the content. Thank you. I love how you do things. If it wasn't for you, I wouldn't be interested in weather. I appreciate it. Thank you. How is the weather in Dallas for the Giants game at 4:30? I'm expecting scattered showers and thunderstorms, but I believe that they have the dorm closed. The dorm will be closed. So the weather should be fine there in terms of the game impacts. In terms of getting to the game, I probably would not be doing anything outdoors, so to speak. Get inside. Safer that way. Unless you don't mind the rain showers. But overall, I think as far as the game conditions, I think they'll be fine. Unless, God, I just didn't think of something. That owner for the Cowboys is nuts. So he might think about this. I wonder if you could do this in the NFL. You have a dome, you have a retractable roof, and you have your most hated team. Would you keep the roof open with the rain and thunderstorms just to mess with the other team? He's crazy enough to pull that off. I don't know whether the NFL would allow that, though. I'm soon to be a student for Earth Sciences. Congratulations, Isaiah. There you go.
Yes.
Could you clarify what phasing is and its effects? Okay. That's actually, for a future atmospheric science, Earth science major, I shall do that. Let me pull up. Let's see here. Let me pull up a good map to use. Okay, this one works. Let me change this here. Okay, so these are your short waves right here. You see these right here? Now, in this case, you have a separation happening. So it marches on through and lifts northward. Now you see this here? This is what's called a developing phase. The two short waves start to interact. This is a partial phase. This is an interaction, but now a full phase. And we have another shortwave right here. Let's see if I can find a full phase. Up here. This is a full phase. Basically what's happening here, and unfortunately I don't have the greatest examples with this output for today, but basically what you're looking at is a combination of shortwaves coming together, like transformers, okay? Now, the best way to understand phasing is watching figure skating. Like when the guy and the girl, and when they're going together and they're about to make that jump, and the guy is lifting the woman up, right? Well, when they're doing that, they're perfectly timed. Their hands and legs are moving at the same time in the same place, and they're positioned so that they come together into one form, in which then the woman is lifted up, and usually not the guy, unless you're in the movies. But you have one woman being lifted up, and you have the guy holding the woman up, and it's one form, right? Now, when that happens, they're moving together at the same speed. So one is not pushing off the other, they're combining. But when one is moving faster than the other, let's say the guy's coming in really fast and she's slower, and he just whacks her right out and steamrolls her and knocks her to the ground, right? That's called shearing, okay? So if you want to see great examples of phasing and shearing of short waves, honestly, to look at it in terms of a physical manner, is watch figure skating and see how, as they are coming together, they're moving at almost the same speed, and they're able to form one form at a constant speed. When you have two short waves that are moving faster than the other, sometimes what happens is the southern short wave is moving too fast and doesn't capture it, and the northern short wave can't capture it, and they remain as two separate storms. Sometimes the polar short wave is too fast and the southern short wave is too slow, so the southern short wave gets torn apart and the polar short wave just drives through, and you just end up with a cold front and a dry weather pattern. Sometimes they phase too early and it causes a big storm in the Great Lakes, and you never get a storm on the East Coast. And then sometimes they phase just right at just the right time to become one big storm on the northern mid-Atlantic. So phasing is nature's ice skating. Literally. You're watching two features coming together at the right speed, at the right time, merging into one storm. It's honestly something that's incredibly beautiful. And I would say another great way to learn about this, you can use the physics and the math, which of course is very important, but study the water vapor satellite picture. It's amazing to watch. And it's literally the same thing as watching ice skating. It really is. As you can see the two features coming together. It really is something beautiful. I heard let's see here. Let's see anything on Discord. Well, it looks like people are enjoying the Discord feed as well. Excellent. Okay. Let's see here. Heard almost the entire Giants' offensive line starters is out against a team with the most sacks in the league. Well, that's not good. So if one short wave completely destroys the other, is the weather equivalent of Tonya Harding kneecapping Nancy Kerrigan? Well, yeah, in a way. I guess you could say that. Yeah. That's one way to look at it. Definitely. Great questions tonight, guys. Absolutely great questions. All right, let's see. What else do we have in our observations? Let's zoom out here. There's our storm starting to evolve here. Some snow in the Rockies. See some of those thunderstorms starting to develop out in the plains. I'm guessing everyone who needs to travel has already traveled, so that really isn't too much of an impact. Honestly, this is one of the better years we've seen in terms of travel for Thanksgiving. Not much of a major impact. How many of you guys, by the way, I'm just curious, how many of you guys have started to get ready to decorate for Christmas? I'm just curious. Because we got a tree up.
The tree out of the box and up.
We got the tree up, yeah, but we have to put the lights on still. Mm-hmm. We'll do that later at some point, right?
Yeah,
maybe.
I got enough to do.
I'll do it.
No.
Yeah.
No.
Yeah.
No.
We'll only put on 600-700 lights on the first part, and the high part, and then we'll go down.
No.
No?
No.
But I think that we should make our tree bright enough for the whole street to see.
Clark Griswold.
Come on. It'd be great. Just wait till we have a house. Oh boy. Let's see here. Next planned travel is Friday down to AC. Well, That it really shouldn't be too bad down there, to be honest with you. Let's see here. All right, so we're doing pretty good with answering the questions. All right, good deal. Let's take a look at that water vapor satellite picture and see if there's anything unusual showing up with our storm. And see, this is what I was talking about with watching the water vapor satellite picture. Right now, you're seeing the two short waves separating. And so as a result, you're seeing stronger diffluence and divergence setting up over the plains. And that's why you're starting to see your thunderstorms starting to develop in Texas and Oklahoma, because you're getting more rising motion. Plus, moisture being drawn northward from the Gulf of Mexico. So you can see the evolution of our shortwave and our upper level lows starting to cut off, and then how the polar jet stream remains quite amplified. I'm just curious, taking a look at something else here. The tropics are dead, by the way, in case anybody has been wondering. That is not going to feature anything. You know what's weird? That the GFS was trying to spin up hurricanes down here for the past couple of days. It's not happening, guys. When you see this type of signal showing up in the tropics, that pretty much shuts it down completely. But let me take a look at the northern Atlantic here. Interesting to see this amplification taking shape here. Pretty good, right on the Gulf Stream too. That could be something, a nice little theme to keep an eye on. So you're doing the Griswold Christmas tree, not as big and no squirrels. SPC has a 7-day 10% chance of severe thunderstorm down in southeast eastern Texas. Yeah, I could definitely see that. Is the Western Pacific also quiet tropically? Let's take a look. Honestly, I have not been paying attention to that all that much. But let's see if we have anything significant showing up here. We have one storm that might be heading towards the Philippines. 99 west. Nothing really strong. Again, it's not so much whether there's development. It's a question of whether or not there's any type of development that would produce like a Cat 3 or higher. And thus far, there's nothing really showing up that's really impressive, so to speak. Let's see here. Any snow? Well, I mean, I'm not sure, that's a little broad. Any snow? I don't know how to answer that question. Any snow in the world? Yeah, there's plenty of snow in the world. We just saw it all throughout North America. North America is actually averaging above normal. So, I'm wondering what is everyone's Thanksgiving plans for this year. We're hosting Thanksgiving this year. I know my cousin's hosting Thanksgiving this year for the first time. So that's cool. Looking forward to that. Looks like another year of very low global ACE scores. Yeah, I mean, ACE, for those who don't know, is a measurement of energy output from tropical low pressure systems. And this is why I have a big problem when they start talking about global warming and stronger storms, because statistically they don't have any support for that. Look, there's a bad theme that happens where people say things that are caused by global warming and they're not. Does not mean that I don't think global warming exists or anything of that nature, but I don't like using hurricanes as a measure for the evolution of global warming, because statistically it's a poor measure. Realistically, it's the opposite of what they're saying. And it opens up a lot of denial of what's happening in the atmosphere. So I really don't like using tropical systems. I think that it's a poor measurement and really bad for us to use. What will be the dominant storm tracks for East Coast this winter? You know what I really like as far as a storm track? I think we're going to see a lot of storms coming out of Texas, northern Texas, Oklahoma, heading towards the Tennessee River Valley, and either jumping towards the Delmarva Peninsula or redeveloping off the North Carolina coast and shooting up the coast. Something like a Miller B type of storm track. But this year, I would not be surprised if we get Miller A type of storm tracks developing out of the western Gulf of Mexico and heading up the coast. Any snow in the coming weeks in the Mid-Atlantic? Okay. Jeez, how many? I only see a couple. Any snow in the coming weeks in the Northeast, Mid-Atlantic. Okay. We've already touched on this. There's potential, but that's all I'm going to say. Nothing impressive, though, guys. Let me be very clear here. I do not see any signal for blockbuster winter storm type scenarios, but definitely a step down in Clipper potential. Portugal in the World Cup in the morning, football and food in the afternoon, sleep tomorrow night. Sounds like a good idea. You know, I can't get into the World Cup. I can't do it. I just can't do it. Like, I tried watching the U.S. game.
Look, if you're into it, you're into it. If you're not, you're not.
But how does a game end in a tie? I don't. I know, you know, I know. My wife is not the biggest sports fan. I know that. But I'm just saying, from a sports perspective, I cannot understand how a World Cup could have games end in a tie. Have a decision made. I don't know. Do it. I don't know. Have maybe like when someone gets kicked, whoever's the best actor as they fall to the ground, and then they get back up like as if nothing happened. Maybe something of that nature. I don't know. I tried getting into it. I can't. All right, we are coming to a close here for the live chat after I pretty much did that with the World Cup. I'll probably go get some hate mail on that one.
Well, you didn't say anything like that. It's just not your sport. That's all.
Yeah, that's true. I can't be involved in every sport, or else I drive my wife nuts.
Yes, you will, and you already do.
Well, how about we get involved in I don't know, polo or... Oh, hold it. We're going to have a special guest. Norman. Let's see if they can see here. Can they see? I don't know.
I'm there. Here.
Yeah, I don't know.
Norman, say hi to everybody.
Say hi to everybody. There you go. This is Norman. This is our pet right here. So say hi to Norman. So as we get ready to end for tonight, and Norman's getting a little... Hi.
There we go. Hi.
He's like, where's the food? He's very shy. I want to wish everyone a happy Thanksgiving.
Yep.
Because of you, I'm able to do what I do. And I really appreciate it. I'm thankful for all of you. Even those who, well, I ask the same question over and over again. It will snow, trust me. But I really appreciate all the support. I mean, we've had like 200 people joining our Discord the first couple of days. That's amazing. And the live chat and the subscriptions, it makes this possible. And there's a lot more coming in the future. Again, we have shirts and stuff coming, but also we're looking to move and we're going to be setting up the weather lab and actually improve the studio. And grow everything and continue to have these chats and stuff. So I want to wish all of you a happy Thanksgiving and just share my appreciation for everything that you guys have given us to allow us to live our dream. Yes, I know.
He's staring at you.
I know. Hello. Yes, there you go. So thank you again, and I hope you have a happy Thanksgiving.
Happy Thanksgiving, everyone.
And as always, stay safe out there.